All right, so today, two little quick warm-ups. Tomorrow, we'll do our 10-minute, our 10-question, 4-minute quiz. Okay, so cosecant 5 pi thirds. So let's see what that is. Here again is how I do it. So you can still do it the way I'm about to do it. You can still do it this way and do it in 4 minutes for 10 of them easily. You see a pi thirds, you should think pi thirds is a 1/2 square root of 3/2, right? It's going to be some plus or minus. 5 pi thirds is in quadrant what? Bless you. Yeah, the 5 thirds means you're in quadrant 4. In quadrant 4, from the origin, you go right and down, so it's positive, negative. Now you're staring at the ordered pair, aren't you? Hang on, I don't like this flared writing. Where the hell did we get? How did I get into flared writing? There we go. Bless you. All right, so now the cosecant is the reciprocal of the sine, which is the y value. So you have to flip negative square root of 3 over 2. When you flip it, you get negative 2 over the square root of 3, which when you rationalize is negative 2 square root of 3 over 3. And there's the answer. Negative 2 square root of 3. It doesn't take long. All right, 5 pi 6, we know it's a pi 6, so we know it's some type of square root of 3/2, some type of 1/2. 5 6, that's just less than 1, that puts us in quadrant 2. From the origin to get into quadrant 2, we go left and up. There's your ordered pair. Cotangent is what, Ryan? You said it, x over y. And remember, for the tangent and cotangents, the 2's divide out. So it's just the numerator of the x over the numerator of the y. That's negative square root of 3 over 1, which is negative square root of 3. There it is. So you could do that very, very quickly. We'll do 4 minutes tomorrow, and then we'll do a 3-minute quiz the next day. And 3 minutes is the fastest I'm going to make you do it for a grade. The day after that, we'll do a 1-minute quiz, which is an optional one. It'll replace either the 4 or the 3-minute quiz if it's higher. Yeah, Daniel Huang last year in Miss Skerhock's class did. He got like 100 right in like 8 minutes or something like that. She gave him like a super jalapeno challenge because it was double dual. And yeah, so I actually had a trophy. I went to the trophy shop and had a little unit circle trophy made up just for him, and I gave it to him. Yeah, he well, tomorrow's Wednesday. Wednesday we'll do a 4-minute. Thursday we do a 3-minute, and then Friday we'll do the jalapeno challenge, which is optional. It's a 1-minute thing, but if you do better on the 1-minute, it'll replace your low grade on the 4-minute or the 3-minute. Okay. All right. All right. So here, let's go to example 11. We're sketching sinusoids, and up to now we've had phase shifts, which remember are horizontal shifts, that have been relatively easy. They have been nice. We basically picked up the graphs and we moved them left or right and set them right back down in the existing critical values, the Sahala-Chala points. Now we're not going to do that. So now, as long as you're fine with making a sacrificial or a rough draft x-axis, you'll be fine, okay? So it says to sketch at least one cycle with at least one negative critical value, blah, 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 just to review. Okay, so to review what our process is, step 1 is to make sure it's in standard transformation form. Is this in standard transformation form? No. Okay, so I got f of x equals, the 3 in the front is added, so it goes to the back, so it's 2 cosine of, and on the inside, I'm going to leave parentheses and put my plus 3. All right, so 2 things need to happen, bless you, on the inside. We need to have the x term first. Do we have the x term first? Yeah, we do. So we don't have to flip those around. And then we need the coefficient of x to be 1. So that means I need to factor out whatever the coefficient of x is. What's the coefficient of x? Pi fifths, right? See that? So on the inside, with extra parentheses, I factor out the pi fifths, and then I set another set of parentheses. Of course, when I factor it out of itself, I'm left with 1. So I'm left with x. I'm not factoring out a negative, so it's still minus. And then here's what I have to come up with. What do I get? What am I left with when I factor out a pi fifths from a 3 pi fifths? 3. Okay, now again, if you don't know how to do that, remember factoring out is nothing more than dividing out. So we're taking our 3 pi fifths, which is what we're starting with. We're factoring out or dividing out a pi fifths. You can do this off to the side, right? This is your workbench. And then you can do stage change flip. So you get 3 pi fifths times 5 over pi. And the 5's divide out, and the pi's divide out, and you're left with 3. And that's the number that goes there. Okay, and then you can distribute back in and see if, in fact, you get 3 pi fifths, which, of course, we do. There's standard transformation form. Okay, so now we're going to come off to the side. We're going to list our, remember the alphabet song, A, B, C, D, P, and R. Remember that one, that version? All right, what is the amplitude of this sinusoid? 2. That's the wave height. Is there a flip here? No, it's not negative, so there's no flip. Okay, so it's just a regular chow law graph. How many cycles do we see between 0 and 2 pi? Thank you. You remember that over spring break. That's just your B value. Okay, now that affects the period, doesn't it? So let's jump down to the period. The period is 2 pi over pi fifths, 2 pi divided by pi fifths. And what is 2 pi divided by pi fifths? Is it 2 fifths or 10? Yes, you're right. It's one or the other. It's actually 10. You stay, change, flip. The 2 pi stays, and then you multiply by 5 over pi. The pi's divide out, and you get 5 times 2. They would make a great multiple choice question, though, to have the period being 2 fifths as an answer choice. So if you need to do stay, change, flip off to the side, do it. The period's 10. All right, what's the phase shift? Right 3. So I'm just going to put a colon instead of equals. I'm just going to put right 3. Now that's where the funkiness is going to come. Our period is 10, and we're shifting it right 3. 3 is not going to be a critical value, so we're going to have brand new critical values, and 0 for the first time. The y-axis will not be a critical point. All right, and then D, what does the plus 3 do? Good. It's up 3 if you want to write up 3, which means your sinusoidal axis is at y equals 3. And then the range. Once we have the sinusoidal axis and the amplitude, we can find the range. The low point is going to be 3 minus 2, which is 1. And the high point is 3 plus 2, which is 5. So if you notice, the graph takes place entirely above the x-axis. All right, now we need our sacrificial x-axis. So come over here, give yourself a little bit of negative room, and put 0 down. This is your rough draft x-axis. Come out to the end and call that 10. That's the period, right? Half of 10 is 5, and then half of 5 is what? You can call it 5 halves, or you can call it 2.5, whatever you're more comfortable with. What's the most important number on this graph before and after a shift, a phase shift? 2.5. Every single critical value in the Sahala-Chala method, axis high, axis low, axis high, is still going to be 2.5 units away from each other, even after the shift, okay? Now, if you want to get the rest of them in here, what's 5 plus 2.5? 7.5. And if you want to go back 1, that'd be negative 2.5. Okay, here's where we have to then think about what the phase shift is going to do. I'm picking the graph up and moving it right 3. Where's 3 going to go? Well, where's 0 going to go? It's going to go right here to 3, isn't it? So 3 is our new y-axis. Here's what you really want to do. Your spacing is going to be important. I want to know where the first critical value is to the left or to the right of the actual y-axis, which is 0, and then I want to know how much the spacing is between them. How far apart are my critical values? 2.5. What's 3 minus 2.5? 0.5. So I'm going to have another critical value right here. That's where this one actually goes. See that? So now I have two things that I need to worry about space-wise, okay? I have this distance right here from 0 to 0.5. That's going to be a small distance. And then I have this distance here, the distance from 0.5 to 3, which is 2.5. Got it? Those are the two most important distances on our graph, because I'm gonna count that heavily. This is the thinking part. This is the planning part. All right, now we can go to our final graph. Here's your y-axis. Here's your x-axis. I'm going to draw it kind of low because the whole graph is, again, above the x-axis. All right, let's do the y-axis first. It's the easier of the two. There is the low point of 1. I'm just going to come up here and call that 5. And then if I bisect that, that's my d value of 3. So that's an easy way to get your spacing correct. Same amount from the sinusoidal axis to the high and the low. All right, now I got to get the x-axis set up. So here's the first point that I'm putting down. I'll switch flavors here. I'm putting down 0.5 right here. Now, do I put my next critical value right there? Is that where it goes? No. I'm not trying to space the distance between 0 and 0.5 the same for the next critical value. The next critical value, if that's a half unit, I need to go 2.5 of those. So it needs to be somewhere about right here. Now, I'll be fine as long as you make it bigger, right? That's going to end up being 3. So again, notice the distance from the y-axis to the first critical point is small, and then the distance between the two critical values is bigger. Okay, that's going to be my new y-axis right there. Now all I got to do is preserve this distance right here. As I make new critical values, preserve that distance. Well, let's go back one. So there's going back one, because remember, you need to have at least one negative critical value. What's that one going to be? What's 0.5 minus 2.5? Negative 2. Hey, I have room for another one. Might as well put another one. Oop, that's kind of too far. What's that one going to be? What's minus 2 minus 2.5? Negative 4.5. Good. All right, now let's add these going forward. So I'm just going to put more marks down, and I'll come back and label them later. Okay, there you go. Now all we got to do is keep adding what to 3? 2.5. So what's the next one? 5.5. And then 5.5 plus 3? 8. And then 8 plus 2.5? 10.5. 10.5 plus 2.5? 13. And we can keep going if we wanted, right? We can keep going. Okay, so now we have what I remember before spring break. I called it setting the table. This graph has the new X and Y axis shown. It has all of your vertical numbers and all of your horizontal numbers listed and labeled. Okay, so we can now accommodate any type of sinusoid graph, a sine, a cosine, a negative sine, or a negative cosine. So if we had forgotten what it was, this is where we return up here and we see that it's a positive cosine. So our graph is just going to be a simple chow law, right? So I go to my new origin, which is at the point 3 comma 3, and I go to the high point there. So 3 comma 5. That's where I start. Now, because cosine always starts at an extreme, I know where the next one's going to go on either side. Okay, as I go to the right, it's high, axis, low, axis, high. There's one cycle going forward. And then if I work backwards, it's axis, which is at 0.5. And then here's where you got to be careful. My next point is low. Do I put low at 0, 1? Is 0 a critical value anymore? Absolutely not. No, it's at negative 2. Okay, and then I go back up to the axis right there. And if I wanted to get 2 cycles, I just need to go one more point to the left or to the right. But that's enough. You get the idea, right? Because that's where I shifted. Remember, the Sahala-Chala method always assumes that you're starting on the y-axis, which is at x equals 0. So where did my y-axis go? If I moved everything to the right 3, where did my y-axis go? It went right 3. So that's where I start for my Sahala-Chala method. Okay, that's what makes it easy. Does that make sense to everybody? That's super important. All right, now I will connect the dots, so on and so forth, and draw a little arrow. Okay, now I can write other equations. Let's go ahead and write other equations. F of x equals, if we've got a positive cosine, let's go ahead and do a negative cosine. Okay, so for a negative cosine, it's going to be negative 2 cosine, parentheses pi fifths, parentheses x plus or minus something plus 3. Remember, the only thing that changes, aside from the negative, the cosine, is the phase shift. Where would I shift over if I wanted to be a negative cosine equation? Same graph, but a negative cosine, 8, right? Or negative 2, either one. Let's shift over to 8. Would it be plus 8 or minus 8 if I want to shift to the right? Minus 8. See, y'all got this down. Once you have the graph and only the critical values are labeled, it makes writing equivalent equations simple. All right, let's do a positive sign. Positive sign is now going to be positive 2 sine of pi fifths x plus or minus something something plus 3. So again, the only thing that's different is now it's a positive sign, and now we have a phase shift. So remember, for sine, we have to look for 2 points. Sine always starts on the axis. Positive sign is axis going what? Up or down? Up. Where are we on an axis going up? 0.5. That's the first easiest one. So I'm going to put 0.5. And again, is it plus 0.5 or minus 0.5? Minus. We got to shift to the right. It's opposite of what it appears. And then the last one, we'll do a negative sign. We got f of x equals negative 2 sine of pi fifths x plus or minus something something plus 3. And for a negative sign, we have to be on the axis heading down. 5. Let's shift to the left once. Let's do, where's another one we could use instead of 5.5? Negative 4.5. So let's choose that. Now, because I That's on the left-hand side, and it's minus 4.5. What shows in the equation? Plus 4.5. You got it. So here's what I promise. If you're in radian mode and you type into the equation on your calculator, we're not going to do it. If you type in all four of these equations, 1 in y1, 1 in y2, y3, and y4, and you hit graph, you're going to see the exact same graph. It's going to trace over itself. Beautiful. There's infinitely many different equations that generate a particular sinusoidal graph. All right. Can someone give me the coordinate of an inflection point? An inflection point, IP, at what? At 5.5 comma what? 3. Yeah, good. That's going to be the axis points. Yeah, there you go. Can anyone give me an interval where the function's decreasing? It's decreasing on the interval from what? 5.5 to 8 would work. Is that a larger interval that works? 3 to 8, yeah. 5.5 to 8 definitely works. But the largest interval is 3 to 8. Yeah. So once you have the graph, we can ask equations that we've been asking for all of our functions. And let's do one more. Let's give a local min. What is a local minimum value? We'll say of y equals 1 at x equals what? 8. Yeah. Or at -2. The local min is 1. It's also the absolute min, right? Yeah. So on and so forth. So those questions can come for free. What's the domain of this function? All real numbers. Yeah, we already got the range. The domain is all real numbers. That's kind of a boring question for sinusoids, isn't it? Yeah. All right. So that wasn't too bad, right? That was what I call an ugly shift because 0 was not a critical value. We shifted it by some amount that was different than what the period allowed us. Now, notice this was still a relatively easy shift. Here's what I mean by relatively easy. Our period didn't have a pi in it. There was no pi in the period, right? It divided out. So we had a nice integer. And then our shift also had no pi in it. In this class, even though it's an honors class, if you don't have pi in your period, I'm not going to have pi in the shift. If you have pi in the period, you will have pi in the shift. Okay, it makes it relatively easy. Now, those people that have taken double dual with Miss Skurhawk, she doesn't make it so nice. She makes ugly, ugly shifts. She'll like have the period to be 10, and then she'll have them shift it right pi thirds or something like that. Ooh, and then it gets ugly. Ooh, because now you have integers with irrationals. Okay? Thank goodness you're not in double dual, huh? You still get the pretty ugly ones. Pretty ugly. Yeah. Do x-intercepts on the original? Oh, yeah, absolutely. You'll see that when we get into the next section, when we start looking at applications of sinusoids, x-intercepts are very important. Does this graph have any x-intercepts? No. But x-intercepts are always, always important. But it's in the context of what the problem is representing. So, like, just to give you an idea, we'll look at one in the next section where it's a stern wheeler on a paddle like a riverboat, and it has this big giant paddle wheel on the end. And we'll look at a point on that paddle wheel as it rotates above water and below water, above water and below water, and it sticks out above water higher than it goes below water. But the x-intercepts end up being the water level itself, the surface of the water. And that's kind of important. So yeah, good question. The x-intercepts are always, always important. We have none here. And they're not always pretty. The x-intercepts, even if we move this down like 2 units, the x-intercepts will be there, but they won't be pretty. And that's where we use the calculator to find them, or we learn algebraic techniques to solve it by hand, taking inverse sine, inverse cosine, and whatnot. Any other questions before we mosey on from example 11? Mosey. Okay. Example 12. Sketch it. Okay, same instructions. We got f of x equals -2 sine of 2x thirds plus pi thirds minus 1. Is this in standard transformation form? No. It's close though, isn't it? Let's go ahead and finish it off. The -2 thirds in the front is good. We got sine. And then we got -1. -1 is at the back where it needs to be. All we got to do is make sure the x term is first, is it? Uh-huh. And then we need to make sure that the coefficient of x is 1, and it's not. It's the 2/3. So now I have to factor out a 2/3 from both terms on the inside, so I have double parentheses. All right? So, of course, when I factor it out of itself, I'm left with 1x, and then I get plus, and then here's the next question. What are we left with when we factor out a 2/3 from a pi thirds? Pi halves. Good. How do we do that off to the side? Here it is off to the side on the workbench. You have pi thirds, that's what you're starting with, divided by 2/3, and then you stage change flip. Pi thirds times 3 halves, your 3's divide out, and you're left with pi halves. Okay? Some people are still getting that wrong. If you're getting that wrong, I'm going to be very, very unsympathetic on the next test. You're going to get everything wrong after that. Okay? So you need to make sure you can do that. That's a given. All right, now we can come up to the side here and list our alphabet song. A, B, C, D, P, and R. What's the amplitude? No, it's not negative 2/3. It's just 2/3. Very good, but now we have a flip. Amplitudes can't be negative because it's a direction, or it's a size. It's 2/3 above the sinusoidal axis, 2/3 below. But it is a flip. There's a negative, so we'll put flip there. All right, the B value is what's the B value? How many cycles do we see between 0 and 2 pi? 2/3. Now, just a reminder, if that 2/3 had been negative, we would pull it out front, right? Because it's an odd function. And on this example, if that had been a negative pi fifths, we would just forget about it because it's cosine, it's an even function. So we can still have negative b values, but remember, for cosine, we just get rid of them, and for sine, we bring them out front. I had that on the retest last test, and some people missed that on their retest. They didn't bring the negative out front for the sine, and it messed everything up. All right. Let's go ahead and find the period. The period is 2 pi over b, which is 2 pi over 2/3, and what happens there? What's 2 pi divided by 2/3? 3 pi? Because it's times 3 halves. The 2 and the half divide out, and you get 3. Again, if you needed to show that in more steps, 2 pi over 1 times 3 over 2. Do as many steps as you need to get your information. Okay, so the period is 3 pi. Now let's look at the phase shift. Which direction are we moving? Pi halves to the what? Left. Okay, so here's what I was talking about. We have pi now in our period, so your phase shift will also have pi in it. What's the d value? What's the down? The -1 means down 1, which means our sinusoidal axis is where? Y equals -1. And now we can get our range. We go -1, and then we go down 2/3. Ooh, we get to work with fractions. What's -1 minus 2/3? Yeah, again, here's your workbench, right? We have -1 minus 2/3. That means it's -3/3 minus 2/3, which is -5/3. Okay, that's your workbench off to the side. And let's see if we can do this one in our head, since now we know how it works. What's -1 plus 2/3? -1/3. Very good. So now notice your range is entirely negative. The graph doesn't have any x-intercepts again. It stays entirely below the x-axis. And now we need our rough draft x-axis. So I'm going to put my 0 right here. And then I'm going to go out the length of one cycle, which is 3 pi. And I'm going to bisect it once to get 3 pi halves. And then I bisect it again to get 3 pi fourths. What's the most important number on this graph? 3 pi fourths. That's how far apart all the critical values are, pre and post shift. Okay, let's add the rest of them if you want to. 3 pi fourths, 6 pi fourths. What would the next one be? 9 pi fourths, and then 12 pi fourths is 3 pi. And then let's work backwards. We're going left pi halves, so let's get some negative ones in there. What would be the first one to the left? -3 pi fourths, and then the next one would be -3 pi halves, so on and so forth. All right, now here's what we have to do. We have to come up with the new value. We're moving it left pi halves. Where is pi halves in relation to 3 pi fourths? Is it before it or after it? It's before it, because pi halves is the same as 2 pi fourths, yes? 2 pi fourths. So 2 pi fourths, -2 pi fourths, is going to be right around there. If you divide that up into like 3 sections, it's going to be that second one. Okay, so that's going to be negative pi halves. That's where our new y-axis went. There's your new y-axis. So this is the distance now that I need to preserve off of the x-axis. Now, where would my next one be if I move to the right? What's negative pi halves? Let's do that over here. Here's our workbench. What's negative pi halves plus 3 pi fourths, which is a quarter cycle counting interval? Well, pi halves is the same as negative 2 pi fourths, isn't it? So that's really negative 2 pi fourths plus 3 pi fourths, which gives us 1 pi fourths. Yeah, and it's going to be right here. So notice all of your new critical values are going to be the same distance just to the right of the previous one. Not in the middle, but just to the right. Okay? And that's going to be pi fourths. So here's what you have to kind of take note of. This distance here and this distance here are not the same, are they? The distance on the left is twice as big as the distance on the right. The distance on the left from 0 to negative pi halves is twice as big as the distance from 0 to pi fourths is. That's what I'm going to be looking at. Okay? So once you have a critical value on either side of 0, you got your spacing. You don't need to label the rest of them on the scratch axis. You can just do that on the actual axis. Got it? Any questions on what we did and how we came up with those numbers? We shifted to the left. We knew where it landed. We put our new y-axis. And then because it was negative, we went to the right, one critical value, which got us on the other side of 0. You always want to have one critical value on either side of 0. Okay, let's go ahead and create our actual axis then. Here's the y-axis. Since everything's negative, I'll draw my x-axis up here. And let's go ahead and do the y-axis first. I'm going to call this negative 1/3. Then I'm going to call this negative 5/3. And then I'm going to bisect that and call that what? Negative 1. Close, right? Negative 1. And then I'm going to draw my dotted line. Make sure that we still know that's a negative 1 and not 1 with the dotted line in front of it. Okay, now it's time for the x-axis. Here we go. So the first thing I'm going to do is I'm going to put my value down right here. I'm going to call this pi fourths. Now, because this is the distance I'm calling pi fourths, I'm going to have to go that distance twice. Boom. Okay? And that's what I'm going to call negative pi halves. And there's your new y-axis. Now, here's all I'm going to do when I look at your graph, your quiz. Is the distance from 0 to pi fourths roughly half the distance from 0 to negative pi halves? Roughly. Okay? If it's the same distance, you're going to lose points. If it's, close to twice as big or half as big, you're good. All right, now I have this distance established, and that's going to be my subsequent distance between subsequent critical values. So I'm going to try and kind of keep that the same. So there's my next one. My next one will be out there. That's not even right. They need to be farther away. There it is. And then I've got one here, one here, one here, one here, so on and so forth. I got room for one more. There we go. Oop, too far. Now I know with Notability you could probably lasso that distance and then just copy it and paste it so it's exactly the same. But I wouldn't recommend doing that because you're not going to have that on a quiz or test. So kind of get in the habit of drawing that distance, eyeballing it, and making sure that it's roughly the same. Okay? So I would give myself full credit so far. All right, now we just got to label them. How far apart are those critical values from each other? They're 3 pi fourths away from each other. So let's label to the left. What would negative pi halves minus 3 pi fourths be? Well, negative pi halves is negative 2 pi fourths. So what's negative 2 minus 3? Negative 5 pi fourths. Okay, so that's going backwards. Now I could just add going forwards, and since we're starting with pi fourths, I already have the common denominator. I'll just add 3 to the numerator and simplify. So what's 1 pi fourths plus 3 pi fourths? 3 plus 1 is 4 pi fourths, which is what? 1 pi, right? Now I'll just add 3 again. What's 4 plus 3? 7 pi fourths. That one doesn't simplify. What's 7 plus 3? 10 pi fourths, which simplifies to what? 5 pi halves. Now remember, that's still 10 pi fourths. What's 10 plus 3? 13 pi fourths. What's 13 plus 3? 16 pi fourths, which simplifies to what? 4 pi. Jasmine, you can take your earbud out. Yeah, that could be the last time I have to remind you for the rest of the year. Does anyone else have an earbud in? I have one in, but it's for recording. All right. If you weren't here the first week of school, remember, when I'm teaching or there's math up there for the warm-up, you should have your earbuds out, ready to pay attention. Okay? I'm sorry, that was 16 pi fourths. Well, we have to go one more. What's 16 plus 3? 19 pi fourths. Y'all could do that, right? You're just adding 3 and then simplifying as you go. All right, now we have all the critical values on the x and y axis labeled. Our new x and y axis is shown. We have set the table. It is now time to put the food on the table, which is the dots, okay? So it is a negative sign. So negative sign starts on the axis. So we're at -1, or negative pi halves -1. And as we go to the right, we move which direction, up or down? Down, down. Negative sign goes down. So it's pi fourths and -5/3. And then we just have the rest of them. Axis, high, axis, low, axis, high. And then we work backwards. And then that would be a high point at -5 pi fourths, a local max. All right, now we just connect the dots. With these beautiful quarter cycle arcs. And we turn the corner and show that it keeps going. So there's 2 beautiful cycles. Now, once we have this, I can ask you all the questions about where is it increasing, where's an inflection value, where's the local max. We already have the range. The domain is all real numbers. So really, it's about writing equivalent equations. So let's go ahead and write 3 of them. Since we started with a negative sign, let's go ahead and do a positive sign. So we're going to get a positive 2/3 sine of 2/3 times x plus or minus something something minus 1. So it's a positive sign, and now the phase shift. I spy 2 places where we can do a positive sign on the graph. What's one of them? Minus pi. Very good. You could also go minus 4 pi. How far apart are pi and 4 pi, where the cycle begins again? 3 pi. That's the period, right? Yeah. Okay. So let's go into cosine land. Let's do a negative cosine. Negative 2/3 cosine of 2/3 x plus or minus something something minus 1. So again, we have a negative cosine and we have a phase shift that differs. I spy 2 negative cosine opportunities. Where's one of them? Pi fourths. Yeah. So it'd be minus pi fourths or plus pi fourths? Minus pi fourths. Yeah. And then the last one, we have a positive cosine. So we got f of x equals positive 2/3 cosine of 2/3 x plus or minus something something minus 1. So there's a positive cosine. And again, I spy 3 places where we could do a positive cosine. Let's do the one on the left again, just to make sure that we know how to go left. It's at -5 pi fourths. So would I put -5 pi fourths right here? I would put positive 5 pi fourths because I'm moving to the left and it's on the inside and it's the opposite of what it appears. All right, there you go. Congratulations. You now know how to graph sinusoidal functions when you have pretty ugly shifts. Okay? They either both will have pi in them or they will both have no pi in them. Comments or questions on those? Not so bad. You might have thought they were going to be harder the way I made them out to be such evil villains before spring break. You probably dreaded all spring break, these 2 types of graphs. And there was nothing to worry about in hindsight, right? Sorry if I ruined your spring break. All right, example 13. This is what kind of most of the extra practice worksheet tomorrow is going to be. If you're given the graph and enough information, can you write the equation? Well, we've already seen this. If we have the graph and we have all of our information shown, all of the axis points and all the critical values are labeled, we can write an equation all day long. But what if we don't start with the b value? Okay, we need the b value for the equation, but we get the period from the graph. Okay, how did we get the period once I knew the b value? It was 2 pi over b. So remember, the period is 2 pi over the absolute value of b. Well, it works the other way around as well. B is 2 pi over p. So that's what we're going to use when we're given the graph. I'm going to be able to find the period and then convert it to the b value, which is what we need for the equation. Okay, so let's come over here and take a look at this first graph. If you want to start listing them, A, B, C, D, P, and R. If I know all those, I got my equation. All right. What jumps out at you right away? The amplitude. What's the amplitude? How'd you get 7? Yeah. Here's a high point. Here's an axis point. The amplitude is the distance from the axis to a high. From 5 to 12, it's 7. That's also the distance from the axis to the low point. So the low point isn't labeled. Can we label the low point now? Yeah. What is it? -2. Good. So this is 7, and this is also 7. Good. So 5 minus 7 is -2. So we can find the range now, can't we? The range should just be -2 to 12. Pretty easy. What else jumps at you right away? It's the first thing I saw. I didn't see the amplitude first. The sinusoidal axis is actually drawn in as a dotted line, isn't it? So what is my d value? It's going to be +5. Yeah, +5. The phase shift is always going to be determined by whether it's a sine or a cosine. So the phase shift, we wait on this. We wait on the c value. What else do I need for my equation? I need the b value, don't I? I need the number of cycles in 2 pi. That's going to be kind of hard to get. So instead, we get the period. Is there a way to figure out what the period of this graph is? Well, we only have 2 x values marked, right? One of them is at a high point, and the next one is on an axis going up. Is that the full length of a cycle? No. What fraction of a cycle is that? Not 2/3. It's 3/4, right? Yeah. There's a quarter cycle. There's another quarter cycle. There's another quarter cycle. And then the last quarter cycle's here. So here's what we know. We know that 3/4 of the period, 3/4 of the period is the distance from 2 to 11. How far is it from 2 to 11? 9. So if you know 3/4 of the period is 9, is there a way to figure out what the period is? 12. Thank you. You just multiply both sides by 4/3, and you get 12. 36/3 is 12. The period is 12. Cool. So now that we know the period is 12, is that the value that goes in the equation? 12? No, we need the b value. So now let's come down here. The b value is 2 pi over 12. What's 2 pi over 12 simplified to? Pi/6. And now we have all of the information we need for the equation. All right. You tell me now. I think we'll have time for one of them. You want to do a sine, a cosine, a negative sine, or a negative cosine? You tell me. Okay, now, if you want to do a sine, we don't have all of the points labeled. We still only have 2 of them labeled. Let's do a cosine, and then we'll do a sine. A cosine is going to start at a high point. So we're going to have f of x equals, what's the amplitude? 7. Cosine of parentheses, b is pi/6, parentheses, x plus or minus something something plus 5. What do I shift over to get a high point? -2. There's a cosine. Let's go ahead and do the sine, since that's the other one that's marked, and Peyton said that one. So we'll do f of x equals +7 sine of pi/6 times x minus 11 now plus 5. Now, if we wanted to get a negative cosine or a negative sine, we would have to find the quarter cycle interval, right? We would have to label those points. How hard is it to find the quarter cycle interval if we know the whole cycle is 12? What's 12 divided by 4? 3. So if we start at 2, where's the next axis point going down? What's 2 plus 3? 5. And then the next point would be 8. And then the next point, 11. And then the next point, 14, so on and so forth, right? So again, once you have the period, you can find the quarter cycle interval just dividing it by 4. All right, so tomorrow we'll finish up with example B, and then I'm going to cut you loose on the extra practice worksheet, which I've already opened in Canvas. So if you finish your homework tonight, when is the homework due? No, I extended it today, remember? Tomorrow's Wednesday. Yeah, it's crazy, right? Homework's due Thursday at 9 a.m. But you have another assignment, so don't put it off, all right? Don't put it off.